Hello everyone. I'm gonna be going over some of the code that I made for this 2D sprite platformer. During this video, I had to make several lines of code with meeting a certain criteria, so I'll be going over those. So I have to go over where I used a if and else statement, and here in our player pawn, we can see on public void move where it moves a player. We can set we can see if we're facing right or if we're facing left. So if we're facing greater than 0, so 1 or 0, if we're facing 1, checks if the player is moving right, and then it sets facing right equal to true, and it'll flip on the x-axis false, so it'll make sure that it's facing the same as where the sprite was drawn at. And then if the direction is less than 0, so it's facing there, it'll say that it's facing left, and then it'll set the facing right equal to false, and then it'll flip it on the x-axis to face the other way through this. And then for a for loop, if we see here, I'm using on my health UI, I use this for loop right here, so it's on an update. So this is going to be running over and over through the 3 hearts that we have on our player. So for this one, it's going to be looping through the hearts, and on the first heart, it's going to check if it's equal to current health. If it is, it'll set it to a full heart, and else it'll empty the heart. So if our health goes down on one of them, it'll sit there and loop and check on these. So this loop will keep happening throughout the updates of how much health I have. And then for my game manager, I had to do a list and a for each statement. So right here we can see that we're gonna throw in the list of game object screens, new list game objects. So I had to add all my main menus into this, and then hide all screens. So for each of those game objects in the screen, it'll sit there and loop through those. And if the screen's not equal to null, it'll check if the screen exists, or it'll set it to false. So this is going to happen when they call for hide all screens throughout these showing audio or showing the credit scenes or any of the other menus that are on there. This one's just going to hide them all. Instead of having them individually labeled, we can do this list. And for the dictionary, we had to make one. So I made one that's going to store the player stats. We can see down here where we initialized it, we set them all to 0. Let's see where we start using them. We'll go to enemy deaths here. Oh, it didn't load it. So we can see we update deaths to the dictionary. We can see that we update our coins on add score. We can start using those high scores to display it on the victory and game over screens. We can see that it's storing it between a key and a value. So the key is that name, and the value is how many it has. So like we can see the key and then the value is going to be how many is actually in there. And so when we go and like add score, we can see that the coins will go up by adding it to the coins. So this is how we can use the dictionary. And then just to show you my screen space, I'm going to be using the main menu as an example. So this one is on the screen, so this can be scaled and it stays the same size. It's just going to be referenced on how big the image to render for your screen size. We have these as panels, so we can see on our game manager canvas, we can see that it's on screen space for these to be rendered into. Space health bar, so this is going to be child objects, so like my enemy frog or my enemy mouse. It'll show that their health canvases is going to be on world space. And then to show some of the UI elements, I'll turn down the music real quick. we can see that we have our cards, we have our lives, we have a score, and then we have our image for a key. We can see that our mute button works. We can see that our sliders are working. These will adjust all the volumes. You can even lower the master volume if you didn't want to just adjust these two. We can see that our play button, our settings button, and our credits button, or our quit button, they're all going to be working, so it'll show it'll quit. You can see that our score will update when we collect coins, our health will update when we take damage, the enemy's health will update when they receive damage. So this is how I got the UI elements to be functioned in the game. And for our play one shot sound, we can see in our audio manager that we have set the SFX to play on one shot during this clip. We used all the play SFX to play for the jump sound, the hurt, collect sound, checkpoint, victory sounds, and the game over sounds. So it'll do this play one shot. And we can see in the throw weapon script, we have the throw at point, or play clip at point, the hit sound. It'll play the hit sound at the transform position, so it'll play it at the weapons. And our audio manager can work through setting the master volume, setting the music volume, and setting the decimal volume. You can see here if we convert them into decibels, so the sliders from 0 to 1 will be referenced off of the decibel scale. And then we can see that the sliders are working by making the adjustments on the appropriate sliders here. We're still using the game manager and audio manager on Singleton, so we can see it's a public class, but we also made it static so the other scripts can find it. And then when we come down to our awake function, we can see as soon as the game manager is awake, when we press play, it checks if there's no game manager. So if there is not one, it'll set this as game manager, but if there already is one, it'll destroy a duplicate game manager. So this is how you can create a singleton to make sure that there's no other version of this running at a time. So like on the door, we can see that we're using the game manager on an instance to call out like win game. We can see that it has key, so we use the game manager to reference the instance of the key. Since we also did the same to our audio manager, we can see like on jump, we can see that our audio manager is instancing that. So there's ways that they're singletons and that they're created by themselves, but they can be used by other scripts. And for this, we're using the player and pawn controllers. So a controller and a pawn. We can see that the controller is reading input and causing the actions to do it, but it doesn't know what it is. So we use that from player pawn, and we can see what's actually happening through math and vectors or force for what the actual player is doing. So we can see that if we were to press up on the W on the or space, we can see space throw button is throw weapon. And then we can come down here and see what throw is actually doing. Is if the weapon prefab is there, it'll stop the code, but if it is there, it'll I'll check if the weapon prefab is missing. So what it'll do is it instantiates the weapon prefab that we have stored. It'll get the rigid body component. It'll see if we're facing right or left, and then it'll throw the weapon using vector to right times the throw force, and then it's using it on impulse, so it's using it by force, not by physics. And then if we see here on our what we're doing on move, so it'll get the horizontal A and D, it'll get that, and then it'll move those on the physics. So it'll use linear velocity, so it'll set the speed that it's actually moving on with either flipping X and flipping Y, or flipping X one way or flipping X the other way. So we can see that we're using physics and force different in this the player controller pawn. And we can see this is using a single purpose. So player controller reads inputs. This is actually what's telling it to do the input, or like our door is handling just the door. We can see our we're using collectibles for the coins. We're using a key collectible, and we use them as single purpose, so they handle themselves and they're only ran by themselves, and it's kind of easier to debug and fix little issues that might be coming up. And for the principles of object-oriented programming, we can see that we have used abstraction in our def class, and then we can override any of these principles, any of the methods that are inside the function to be called and overridden. So this is a way of abstracting code into the game, so that they can doesn't have to understand what's happening. It just has to know what to call. And we can see like inheritance is like death destroy inherits from death destroy inherits from that death script. So we can see here it'll call the override of that die, and then what's actually happening is it's destroying the game object. Also an example of polymorphism. So we can see that we can use die in many different ways. We can call die and then put anything else in this code to allow the object that we're destroying or dying, or if in another class we have it moving in a different way or making different noises, we can call them just using an override on the die function for the specific object. For the encapsulation, we can see enemy health. This is how we're able to keep information stored within the class using, we have like a private integer of current health, but we can see when to get them to take damage, we had to make a take damage. So we can see, yeah, public void take damage by the integer damage amount. So we can see in here, we're still able to hurt the enemy on their health, but it's not using their private variable. And just keeping like frame rate independent stuff, we have like time delta time. We can see that we're running only off of Unity's frame rate, so times or your internet speed or like a lag spike won't affect the speed that the sword is coming out. When we talk about colliders or boundaries, so I have colliders that stops movement from going through colliders. And when we think about triggers, we can think about like these boundary boxes that my player can go through, and it doesn't stop the movement, it just triggers an event. Or like on our coins, we can see that on their colliders there is triggers, but we can see on our player, he doesn't have a trigger function set. So it's not triggers will allow you to move past the object, and colliders will block the movement so that enemies or your sprites can't move through them. Like on our coins, we have this collectible script, right? So we can see on trigger enter. So when one object comes in with another one, we'll check to see if it's the player, and if it's not the player, it'll stop. But if it's is the player, it'll collect that coin, and then either hide or destroy the game object. So here we're hiding it at the end of this on trigger enter function, and then after collecting score and all that. And we do have some different versions of moving using vectors. So like on our throw weapon function, we have a weapon add force, which is our vector to right times a throw force. We'll be able to multiply our vectors for x and y using a multiplier of throw force. In our game manager, we have setting position. So player dot position equals checkpoint position, sets that current position in the variable. And player pawn uses movement by linear velocity using the vector 2, direction by move speed, linear velocity. Camera follow, we can see that we're adding our vectors here. And so we can see that our throw weapon has the force mode impulse, and it is using gravity and linear dampening. And I posted a build on the Google Drive. I'll get the link in the video. In the next video, I'll show a little bit of gameplay throughout, show everything works.